parallel combination of capacitors. That means capacitors combined with each other in a parallel arrangement. Fine. So first, let us understand what are these capacitances of these capacitors. C1, C2 and C3 are the capacitance of the three capacitors I have used. Okay. Then, what are the charges on each plates of each capacitor? C1 has a charge of plus or minus Q1 combination. C2 capacitance has a charge of plus or minus Q2 combination, and C3 has a charge of Q3 plus or minus Q3 as their combinations. The charges on the plates of each capacitors are different. Q1, Q2, Q3. C1, C2, C3. Potential difference, potential drop between each capacitance remains the same. So, the potential difference between the plates of C1 is V. Similarly, for C2 also V. For C3 also V. So, very important to remember, in a parallel combination, the potential difference between the plates remains the same. This is a point to be remembered. Now we have already learned C is equal to Q by V as the formula for capacitance. Fine. So let us write using this information. C1 is equal to Q1 upon V. C2 is equal to Q2 upon V. C3 is equal to Q3 upon V. Therefore, if we combine the charge Q, we get Q is equal to Q1 plus Q2 plus Q3. From this equation, we can write C1V plus C2V plus C3V, and the effective capacitance, C is called as the effective capacitance in parallel combination, can be written as, from this equation, Q is equal to CV. Let us substitute CV here. So, we can take V common here. We get C1 plus C2 plus C3. So, now cancelling V on both the sides, we have C, the effective capacitance of a parallel combination for C1, C2 and C3 as C1 plus C2 plus C3. So, by a parallel combination of capacitors, what did we do? We increased the capacitance. This is a point to be remembered and noted. Suppose I have n number of capacitance or capacitor